So in this lesson today, I'm going to go over perimeter and area of polygons, adding, subtracting, and multiplying polynomials. So by the end of the lesson, you're going to be able to find the area of parallelograms and triangles with polynomial side length. So if you look at this image here and I say ponder the perimeter, find the perimeter of the rectangle, can you do that for me? So hopefully you know that this down here is 7a, right? And this over here is 12b because opposite sides in a rectangle are congruent, right? So you could do 2 times 7a plus 2 times 12b. 2 times 7 is 14, so that would be 14a, plus 2 times 12 is 24, so that would be 24b. So that would be the perimeter of that rectangle. So today, again, we're going to add and subtract and find the perimeter of polygons. So any expression that's a combination of one or more monomials connected via addition or subtraction, that's what a polynomial is, okay? So an example of that is 2x squared plus 6x minus x to the third plus 3x to the fourth plus 2. When you write polynomials, they should be written in standard form. That means standard form of polynomials where the terms are written in descending order by degree, okay? So an example of that is when the degree is this up here, right? So we're going from the biggest exponent to the smallest. So 4x to the third minus x to the second plus 2x minus 5. And this is our constant right here, right? Because there is no x to it. Remember, this is an x to the first. So notice obviously that the exponents are getting smaller. So remember also that you only combine like terms. So example 1, adding and subtracting polynomials. So what is the difference? So what I like to do with these when I set them up is I set them up in descending order and I subtract, okay? So, and it says difference, so that means subtraction. So we're going to do 5x to the third minus 3x squared plus 2x plus 1. Notice I wrote it in descending order, and I'm going to subtract from it 5x squared. I got a minus 7 over here, and I got a minus x to the third. Now we are subtracting that whole thing. So what does that really mean? That means we're going to change some signs, okay? So I'm going to go ahead and change the signs and everything in that parenthesis because we're subtracting it. So if we subtract a negative, that becomes a positive. This is going to end up being a negative, and this is going to become a positive. And notice there is no x to the first in what we're subtracting, okay? So I'm going to put this down here. So we add 5, and remember there's always a 1 in front of there, so that's going to be 6x to the third. We got 2 negatives. If you combine 2 negatives, you just get a bigger negative, so that's going to be 3 and 5, that's 8, so that's negative 8x squared. Bring down the 2x because there is no other x to the first, and then you add the 1 and the 7, so that's going to be 8. So this one says, now answer the following questions about the difference in sum of the two polynomials. So it says number of terms, so we have 1, 2, 3, 4 terms. The leading coefficient is the coefficient that's out front. That's this right here. So that's 6. The constant term is something that the number that has no x attached to it. And then our degree is going to be what the highest exponent is, the biggest exponent. Okay, so this is going to be a third degree polynomial. So now I'd like you guys to go ahead and add these two together and answer those questions down there at the bottom, A, B, C, and D. All right, so once again, I'm going to write these in descending order. So I got 5x to the third minus 3x squared plus 2x plus 1. This allows me to line up my like terms. This time we got a minus x to the third. And remember, we're adding these this time, so we're going to keep the signs the way they are. We got a negative 7x over here. We got a plus 5x squared, okay? So this time we're going to get 4x to the third. And remember, I told you guys that you always subtract when there are different signs and keep the sign of the bigger one. So we're going to do 5 minus 3, and that would be obviously plus 2x squared. Bring down that 2x again because there's no x to the first in the other term, and this time we are subtracting 7 from 1. Again, just subtract 1 from 7 and keep the sign of the bigger term, okay? So it says number of terms. Again, we have 4 terms. Leading coefficient is this guy right here, okay? let's do it in a different color. 4. The constant term this time is -6. And the degree is this right here. So we still have a third degree polynomial, okay? Because that's the biggest exponent. So for example 2, it says find the perimeter by adding and subtracting polynomials. It says a model of a house is shown. What is the perimeter in feet of the model? So basically all of these equations are feet. It says what is the perimeter? So first I want to talk about what is perimeter. Isn't it the distance around the outside of an object? So that's what I want you to write here. Distance around outside of an object. Okay, the next thing it says label the side that has one tick, or one tick, and the side that has 2 ticks. Okay, so basically this would be up 6x minus 4 here, and this one over here would also be 12x plus 3, right? So then it says find the perimeter of the house. So what we want to do is we're going to do the 14x plus 13. You know what, I'm going to move, let me see if I can, I'll see how we can do this over here. So let's do this 14x plus 13, this down here. 14x plus 13. Then I'm going to do 2 times this up here, okay? So I'm going to go 2 times 6x minus 4. And notice we also have 2 of these, right? Let's do this in a different color. 2 of these, yes? So I'm going to do 2 times our 12x plus 3, okay? So we're going to move all this over here. 14x plus 13. 2 times 6x is 12x. And 2 times -4 is -8. And then we got 2 times 12x. That's 24x. And then we got 2 times 3, and that's 6. So now we're just going to combine all these. 14 and 12 is 16, and 16 plus, 14 and 12 is actually 26. 26 plus 24 is 50, okay? So that's 50x here. And then we got 13 and 16, that's 19, minus 8, that would be 11. So that would be the perimeter of the house. All right, let's see if you guys can find the perimeter of this triangle right here by adding these 3 sides together. And again, remember, line up the things that are the same sides. Okay, so I'm going to start at the bottom. 4r squared minus 6r plus 1. Then I'm going to go to here, over here. Yeah, if my pen would choose that, yeah. So I'm doing 5r squared plus r3. Notice I'm lining up like terms, and over here we've got our, whoops, I didn't do the squared, did I? 5r, yeah, I did actually. Then we're going to do 7r minus 8, okay? So once again, we're adding all of these up. So that's going to give us 9r squared. 7r minus 6r would be r, positive r, right? And then we've got 5 and -8, so, I'm sorry, 4 and -8, so that would be minus 4. So that is our answer there. Okay, right there. All right, let's continue on. This one says example 3. Taylor has a garden shaped like a trapezoid. Each side length is represented by a polynomial expression. If the perimeter of the garden is represented by the expression 7x to the 4th, 9x to the 3rd, plus 9x to the 3rd, minus 6x squared, plus 8. Where's the extra question here? Yeah, if the perimeter of the garden is represented by the expression, it basically says, oh, it's missing here. What is the length of the missing side? What is the length of the missing side? That's what's missing right here, y'all. What is the length of the missing side? So, what is the length of the missing side? It was there. I just had it covered up. So let's go ahead. I'm going to write this one right here first, and then we're going to write this one, and then this one, and we're going to combine our like terms. Okay, so here again, we're going to go 4x to the 4th. Now, I notice that there's no x to the third, so I'm going to do 0x to the third because I want to give a space for it. Minus 2x squared and minus 6x plus 0, okay, because there was no constant. Okay, now I'm doing this for a reason because I can then line up my different parts with what is like it. So we've got a 4x to the third here plus 6x plus 6, okay? And then we're going to do this one up here. And remember, we're adding all this stuff, right? Then we got 3x to the fourth and a minus 3 over here, okay? So I just did that first one so I could line things up. So we're adding 4x to the fourth and 3x to the fourth, so that's 7x to the fourth. We're adding the 4x to the third. And then negative 2x squared. The x's cancel each other out. Y'all notice that? These two things cancel each other out. So then we've got 6 minus 3, which is plus 3. Now, that is the sum of those three sides. So what we now need to do is take this right here and subtract this from it, okay? So we're going to subtract our sum. So we're going to go 7x, you know what, let me do it in a different color here. 7x to the fourth plus 9x to the third minus 6x squared. I'm going to do a plus 0x here, plus 8. Now we're going to subtract from it the 7x to the fourth. And I'm just going to actually make this a plus 4x to the third minus 2x squared plus 3. Now notice we're going to have to change all those signs. So I'm going to go back in here and I'm going to make this a minus, that a plus, and this a minus, okay? So when I do that, I should get my answer. So these two cancel each other out. 9 minus 4 is 5, so this is 5x to the third. Then we've got negative 6x plus 2x, so that would be minus 4x squared. And then there's nothing here. And then we got 8 minus 3, so that's plus 5. So that's our answer right there. That's what that side, the question mark, is equal to, okay? Because if we added that in, and you could go ahead and try it, when you add this in, you should get our sum, okay? And what I mean by that is, let me show you. So if you add this to this, you get that, right? You add negative 4x minus 2x, you get negative 6x. You get 5 plus 3. Guess what you get? 8. See that? So you can check it. All right. Go ahead and do the you do here. Subtract. What in the world happened here? Hold on a second. Okay, so it says you do 3. Subtract 8x squared plus 2x minus 6 minus 5x squared minus 3x plus 2. Danielle's completed the operation, but she made an error. What is her error? Correctly complete the operation. So let's see what she did. So she's got the first term written correctly, but then she should subtract all of this, right? So if she subtracts, that would make that negative, that positive, and that negative. So let's see if that's what she did. It does have a negative 5x, so that's correct. But this should have been a plus, right? And that should have been a minus. Okay? So then this would have been a plus, and that would have been a minus. So that means this would have been this part. So when they're combining the terms, they're doing side by side here. Horizontal method instead of vertical method. I just like the vertical method more. So that one's right, okay? But this one should have been plus 5x, right? And then this should have been, when you combine those two terms, it should have been negative 8. So it should have been 3x squared plus 5x minus 8 was the correct answer, okay? All right, now let's talk about area. Area is the space that an object takes up. Okay, so area formulas, parallelogram is equal to the base times the height. That's what these parentheses mean. Triangle is equal to the base times height divided by 2. Okay, so find the area of the parallelogram with a base of x squared plus 7x minus 5 and a height of 3x squared minus 2x minus 1. So again, we're just doing base times height. So it means we're going to multiply these two equations by each other, okay? And I do want to point out to y'all that height is typically, it's vertical, it's a perpendicular to the base, okay? So your height of the triangle, and I think this moved on y'all's notes when I printed it. I don't know why. Well, no, actually, did it? Let me see. It didn't move on this one, but it moved on the triangle below it. So we'll talk about that in a minute. Anyway, so what we're going to do here when we do this problem is we are going to use the box method. So I'm going to write them both in descending order. So I'm going to do x squared here, 7x, and minus 5. And then on the side, I'm going to do 3x squared, a minus 2x, and a minus 1. Okay, so I'm going to create myself a box here. And I always write these in descending order when I do this, even if they didn't give them to me in descending order, because what that does for me is when I compute this in the diagonals, I will be able to see like terms, okay? So when I multiply 3 times 1, I get 3, right? And when I multiply x squared times x squared, I get x to the 4th. Remember, when you multiply exponents, you actually add them, okay? So then when I multiply the 3 times the 7, I get 21, and x squared again, and x, you know what, let's change this to a different color. Let me try that. We're going to do red here. So that's 21, and our x squared times our x is x to the 3rd. Now, I'm going to do the one that's over here in this box. So we got an x squared times a negative 2x. So this is going to be negative 2x to the 3rd, okay? Now, notice that we have our like terms in our diagonal there. So we're going to keep going. We're going to multiply negative 5 times 3x. Let me erase that because now it's getting kind of muddy. Okay, so we're going to do negative 5 times 3x squared, so that's going to give us a negative. Yeah, it'd be good if I didn't erase my line, right? So that's negative 15x squared, okay? Now I'm going to do 7x times negative 2x, so that's going to be negative 14x squared. And then I'm going to do my x squared minus 1, so this is just going to be minus x squared, okay? Are you starting to see your like terms there in your diagonals? Okay, so... And then I'm going to do the next one, which is negative 5 times negative 2. So that's going to be 10x. And then we've got 7x times negative 1. So that's negative 7x. Let's see if I can find me one more color. I'm just going to go back to the blue, y'all, for my negative 5 times my negative 1. So that's going to be 5, okay? All right, so... now all we're doing is combining like terms. So we have our 3x to the 4th, right? So we're going to now combine the 21 minus the 2. So we got 21x to the 3rd minus 2x to the 3rd. So that's going to be plus 19. Let me get my red here. 19x to the 3rd. Okay, now we're going to go green. Let's see, we got negative, negative, negative. So that's going to be 15. 14 plus 1 is 15. So that's 15 minus, negative 15 minus 15, right? So that's going to be negative 30x squared, okay? Then we're going to subtract 7 from 10. So that's going to give us plus 3x, and then we got our 5. So this, I like doing it like this because I'm really making it very clear to y'all that the diagonals are where our like terms are. So that's our answer there. Okay? So the next one says find the area of a rectangle with a base of 4x squared minus 2x plus 4. Okay? So on this one, again, I'm going to do our 4x squared. You guys can pause the video, go ahead and do this, and then you can come back to me when you're done. Over here on the left, we're doing x and a negative 5. So this one's a little smaller. I was trying to be nice to y'all. So we got our terms here, right? Again, x times x squared is going to be 4x to the 3rd, okay? Then we're going to multiply 2x times x. That's going to be negative 2. Let's do this in another color. Negative 2x squared. 4x squared times negative 5 is going to be negative 20x squared. Then we got our 4 times x, so that's 4x. We got our negative 2x times negative 5, so that's going to be 10x. And then we've got our 4 times negative 5, so that's going to be negative 20. So don't have anything like our 4x to the third, so we're going to write 4x to the third. We got a negative 20x squared minus 2x squared, so that's going to be negative, let's do that in red, negative 22x squared. We got a 10 and a 4x, so that's going to be plus 14x. And then we got our minus 20. Make sense to everybody? Okay. All right, so the next one's a little more complicated because the area of a triangle is base times height divided by 2. And this is where that triangle should be right here, y'all. It should be there. I mean, that right there shouldn't be there. It should be over. Because that's what tells us this is a height. The height is equal to x squared minus 2, okay? So remember, the height is always going to be a right angle to the base, okay? So on this one, I'm going to do our 6x squared, 12x, and minus 5. And then over here, I'm going to do an x squared and a negative 2, okay? Again, using my box method. Okay, so x squared times 6x squared would be 6x to the fourth. Now I want you to notice something. 12x times 12x squared, or times x squared is 12. Let me do this red. Come on. 12x to the third. Then we got our negative 5 times x squared. Negative 5x squared, okay? Then notice we have the 6x squared times negative 2. So this is actually going to be our negative 12x squared. There's our like terms there. Now why don't they line up? Because we didn't have an x to the first in our vertical over here. We didn't have an x to the first there. Y'all see that? Okay, that's why. All right, so let's keep going. 12x times negative 2 would be negative 24x. And then I'm going to go back to black. Negative 5 times negative 2 is positive 10, right? So what we're going to do here is we're going to now write this whole term down. I'm just going to do it all in black. 6x to the fourth. We have plus 12x to the third. Negative 12x squared and negative 5x squared is 17, negative 17x squared. Then minus 24x plus 10. Now, listen. What we have to do with this is we have to divide it by 2, okay? So all of this needs to be divided by 2 because it's base times height divided by 2. So that means this is now going to be 3x to the fourth plus half of 17 is 8.5, right? X to the third. Did I have 17? No, was that right, y'all? 12x to the third. Oh, no, that's 12. Sorry. My bad. Can't read my own handwriting, y'all. So that was 6. Sorry. So that's 6x to the third. Half of 17 was 8.5. Yep, so that's 8.5x to the second. Minus 12x plus 5. Okay. So remember, when you do the other one, and this one, you should have your diagonals again for you do 5, that you're going to divide everything by 2 when you're done, okay? So this right here was your answer. All right, go ahead and do the next one. Pause and come back to me. So we got 5x squared minus 8x and a 1. And down over here, we got our 2x squared, a negative 9x, and a minus 4. Now this time you are going to see that what we talked about the diagonals, it's going to work out because we've written this in descending order and there's nothing missing, okay? So let's start with that 2x squared times 5x squared, so that's going to be 10x to the fourth. Then we're going to do negative 8x times 2x squared, so that's going to be negative 16. Let's do that in a different color. Negative 16x to the third. And if we do the 5x squared and the negative 9x, that's negative 45x to the third. Y'all see what I'm doing? Okay. So now we're going to do 1 times 2x squared. So that's going to be 2x squared. Negative 8x times negative 9x would be positive 72x squared. And then 5x squared times negative 4 would be negative 20x squared. All right, let's go back to our black now. And then 1 times 9, negative 9x would be negative 9x. Negative 8x times negative 4 would be positive 32x. And then I'm going to go back to my blue again. 1 times negative 4 is negative 4. Okay, so now we're combining our like terms again. So we're going to have 10x squared. Or sorry, x to the fourth, 10x to the fourth, right there. And then we're combining these two right here. So 45, so that's 61 minus 61, x to the third. Negative 20, so that's 74 minus 20. So that would be, what, 54? Plus 54x squared. So what I got, and then if I do 32 minus 9, that's going to be 23 plus 23x. And then we got our minus 4. Okay, so once again, remember, we got to divide all of this by 2. So that's going to give us 5x to the fourth minus 30.5x to the third. Just divide these by 2 in your calculator, plus 27x squared plus 11.5x minus 2. That is our answer right there, guys. Okay? All right, this next one's kind of tricky. So let's talk about it. So it says, you plan on making a wall hanging that contains 2 small mirrors that are 8 inches wide, or x inches wide. So this is a width right here, guys, okay? X inches wide. Let me move this so we can see it, okay? And 2x inches tall. Okay, so this is our height right here, okay? That's a height. That's a height. We're going to need that in a minute. And then it says the outer back frame is 2 inches wide and there are 4 inches between the mirrors as shown. So, find the area. So we need to find the width and the height, right? That's what we need to find. Because to find the area of this, we need the length times the width, or the width times the height, okay? So let's find the width first. So look here, we've got 2 and x and 2. So to find the width, we're going to do 2 plus x plus 2. So that's going to give us x plus 4. Everybody see that? Okay, now we're going to talk about our height. So we've got this 2 here, we've got this 2x there, we've got that 4, we've got that 2x, and we've got that 2. So we're going to do 2 plus 2x plus 4 plus 2x plus 2. Okay, so 2x plus 2x is 4x. 2 plus 4 is 6, plus 2 is 8. Okay, so what are we going to do with our width? And so we're going to multiply our width times our height, right? Or base times height, right? Isn't that what we're doing? Okay, so width times height. Width is the same thing as a base, okay? So what we want to do is we want to do our x and 4 here, and our 4x and our 8 there. Going to use our box again. So 4x times x is 4x squared. 4x times 4 is 16x. X times 8 is 8x. 4 times 8 is 32. Okay? You should notice that we have our like terms right there in our diagonal, right? Okay? So we got 4x squared. 16 plus 8 is 24x, and then plus our 32. So that's our answer right there for the area of that triangle, right? So pause.